First of all, thanks again for coming out for our program, Energy Modeling and Commissioning. I want to mention a couple of upcoming events. Next month, September 25th, we're going to have this program repeated in Chattanooga, Tennessee. October 26th of this year, we're going to have Weatherization Day in Knoxville, and we're going to get together and weatherize up to 2 homes in East Knoxville. So if you want to volunteer for that, or if you have cruise raider experience, if you'd like to volunteer cruise raider time, that is something we're looking for right now. We have Bruce Landville, who's in the room. Bruce, how you doing? And Bruce is helping us out with that, so thanks a lot. And if you're also interested in sponsoring Weatherization Day, we're currently looking for sponsorships. Speaking of sponsors, we have our education sponsorships and our overall sponsorships for the chapter. We have at a silver level, ecological energy systems, green spaces, partners development and training. At a bronze level, we have Benefield Richter Design Build Company, Blaine Construction, Brewer Ingram Floor Architects, Elizabeth Eaton Architecture, Facility Systems Consultants, Hickory Construction, Johnson and Gailey Construction, Gallian Construction, Knoxville Community Development Corporation, Marvin Concepts, McCarty Holstaff and McCarty Architects, the O'Hanlon Group, Oak Ridge Associated Universities, S&M Sales and Marketing Consultants, and the Shaw Contract Group. Without further ado, it's my great pleasure to introduce our speaker today. We have with us today Wayne Robertson. He is an energy consultant with over 30 years of experience in the energy conservation field. He is a registered professional engineer, certified commissioning agent, and has been a lead AT since 2001. Wayne received a Bachelor's of Industrial Engineering from Georgia Tech and an MBA from Georgia State University, and is a nationally known speaker and writer on diverse subjects. He also started Energy Ace Incorporated, which has been involved with more than 180 lead projects.
Before we get started, just a word from my sponsor. My sponsor is Energy Ace. It's a company that I work for. We're a sustainability consulting firm. James said we work on 180 different lead projects. We're staffed with architects and engineers, but we do not practice design, support those that do design buildings. In fact, my elevator speech is that we help people design, build, and operate green buildings. We don't design them, build them, or operate them. We help all those to do. That's our particular shtick. We work on those 200 lead projects, about 89 are now certified. The majority of those are gold, so we work on the high-end market. It's been a great and fun business to be in. We're very active members in the USGBC and AIA, American Institute of Architects as well. How many architects do we have here? Okay, this is good for AIA CEUs. John? Yes. Yeah, hey, how you doing? Good. Good to see you. Sign sheets going around, and you put your AIA number. I've got any engineers in the room, the PDs? Okay, ditto for PDA. You can fill that out. We'll get you the right paperwork. And this is also good for credentialing mates. Do you have any lead APs in the room? Just a few. Okay, great. So you get a CMP for this. So and you get food, and you get dessert, and if you're lucky at the end, you might get a baby root bar. That's a little treats here for us. So let's get started. This talks on energy modeling and efficiency. So that's, I'm going to talk about LEED writ large. I'm going to talk about those two particular technologies and why it's important, what are the 3 options, what do you do with an energy model besides have to pay for it, have it done to your project, how can it help you as a designer, builder, and owner have a better project, and same thing with commissioning. How can you be a smarter consumer of commissioning services? We're not going to train you to become a commissioning agent this afternoon, but really how to be a smarter buyer of those services in the future. And I've already passed out your quiz. This will be administered at the end, or you can fill this out. It'll be graded at the end. So you can fill this out as we go along. I'm asking you to work in teams on this. And sir, you are a team to the lady to your right. She's single tonight. Okay, so we'll have the 10 questions that are printed and then a surprise bonus question at the end. And asking you to work in pairs. Okay, so while you're thinking about that, I want to kind of get you in the right mood here. I know that you're like, yeah, okay, but just in case. Still got a screen through there, a few things to give away. And so I'm going to just kind of assess the general knowledge of the group here. How many How many LEED certified projects do you think there are in the United States? How many LEED certified projects? What's your guess, sir? You have a guess? LEED certificates. Is it A, 67,000? Is it B, 7 to 8? Is it 8 to 9,000? Is it 10,000? Or is it, there could be an E option. Is there more than 10,000? Don, you got an idea? Don thinks it's B. How many people think it's B? Raise your hand. You think it's B? Got a lot of B's. Got the A's in the room? The A types? A couple A types? Okay. Who thinks it's over 10,000? Anybody? Got a couple over 10,000? Okay. And the answer is 13,000. Can you catch them? Who else guesses over? All right. I'm not that. Congratulations. All right, congratulations. Okay, now, here's the follow-on question. How many LEED registered projects are there in the United States? Now, I'll give you a clue. I'll give you a clue that this number will always be greater than or equal to this number. Always be more or equal. Okay, so it's a bigger number. Okay, so A, 15 to 20,000. B, 20 to 25,000. Got a few B's, okay. Anybody think it's 25 to 30,000? Letter C. And how about the D category, 30 to 35? Okay, let's see. Did you raise your hand twice? No. She raised her hand. All right, the answer is none of the above. It's 43,000. Anybody guess that? Did you do it?
I said B. Yes.
All right, there you go. Okay, congratulations. Sugar.
Yeah.
Hope you'll get a sugar high.
Yeah.
Okay, one more question. One more question. This has an interesting answer. How many LEED APs are there in the United States? Now, this is just a random. I don't have a multiple choice on this. So what do you think? What's your guess?
I'm going to say it's going to be more than D.
Okay. I think you're right. I think just for your courage. There you go, sir. All right. So what's the number? How about 100,000? Anybody? 75,000? 150,000? An amazing number. 146,700. And this is a few months ago. This information is, I mean, all these numbers have gone up since that time. So to me, this is kind of interesting that, as you said, there are more than 43,000. In fact, there are 3 LEED APs, 3 or 4, I guess about almost 40, 3 or 40 LEED APs for every LEED project out there. So there's a lot of us. And that explains all the competition that we're seeing. And of course, everybody knows that LEED is a big deal in the building industry. In fact, LEED is so big that they have built their own town. Right here. Anybody know where this is?
Alabama.
There you go. All right. I don't know how
We want Bruce stuff too.
Sorry. Okay. So LEED's built their own town in Alabama, and it's right there. You can see it yourself. It's on right out like it. So it's a lovely place. Okay. So we're going to try to unravel what I call the 2 LEED mysteries right here. Be paying attention to your quest, your test, because you're going to be getting these answers as you go along. In most cases, I'll give you the answer. So, energy modeling is one of 3 paths to meet EAP2. I didn't make these up. As somebody else said, EAP2, it stands for Energy and Atmosphere Prerequisite 2, and all you lead APs know that. EAP2, called Optimized Energy Performance, and it applies to all B, D, and C projects. What does B, D, and C stand for, Greg? B, D, and C? Jim? Audrey?
Building design and construction.
Building design and construction, congratulations. Which includes NC, what does NC stand for? Construction. School, what does school stand for? Okay, good, it's a good group. All right, and then CS? Portion, very good, okay. So we'll try to answer the question, what is energy modeling? What's it good for? How does it help? And then ditto for building commissioning. Now, building commissioning is required for all LEED projects, not just B, D, and C. We'll talk about budget building commissioning. So first we'll launch into energy modeling. EAP2 requires a 10% improvement in energy efficiency over a base building. And unless you're doing a major renovation to an existing building. Some people, by the way, get confused about What? Gee, why not got an existing building? Shouldn't it be E-bomb? Shouldn't it be existing buildings O&M? Rating systems? No, if you're doing a major renovation, even to an existing building, it still falls under new construction. Because if you ever read the fine print on the rating guide, it says new construction and major renovation. So read the fine print and you'll know this is going to be an NC type of project.
But how do you define major renovation? 50% of the original cost of the building, or what?
Major renovation would be new HVAC or substantially new. It's soft and fuzzy. It's not a hard definition. But basically, if you're doing an HVAC, heating, ventilating, air conditioning retrofit, lighting retrofit, you're doing something to the envelope. You're changing the windows. You're doing something to the roof. That's enough.
All right, do you have to do all of the above? Because I've got a building that's HVAC, lighting, no envelope, and paint. And they're saying it's commercial interiors, and I'm saying, I think you're treading a very thin line, but we can talk about it later, don't worry.
Yeah, let's talk about that after class. But that would be a puzzle. We'd have to move that a little bit. But if you are working on an existing building, then EAP2 requires a 5% improvement, not a 10% improvement. So it actually makes it a little bit easier for you to score points. So when somebody comes to us and say we've got a major renovation of the existing building going on, we get real excited because we're able to help them earn a lot more energy points just because it's just that much easier. Now, how many folks here do business with or work in federal buildings? Greg, of course, and quite a few of you. Well, you've got the guiding principles, which is a whole other kettle of fish right here. And the target for guiding principles is very ambitious. It's 30% better than actually 90.1 2007. So that's very ambitious. But that's what energy modeling has to help you accomplish in your buildings. Now, energy modeling is a computer simulation that predicts under idealized conditions, right here, idealized conditions, the energy consumption of the base building and the building as designed. And the energy modeler will give you a number that turns out to be a percentage of improvement, and then you go to the lookup chart, and you're on the 10% chart, it's a new building, or you're on the 5% chart, it's an existing building, major renovation, and bingo, there's your numbers. Now, I want to say something about the idealized conditions right here, because the energy model is based on 20-year average weather. It's based on the assumption that the building is operating exactly the hours that you told the energy modeler were open from 8 to 5, and by George, it's 8 and 5, not 7:58, not 5:01. There's no PTA in the evening. There's nothing else going on. It's exactly whatever you said you put in the model. Number 2, and then number 3, it assumes that everything in the building is working perfectly. All the filters are clean. All the belts are tight. Who here works in buildings? Do they all work perfectly? No. Neither do any of them that I've ever seen. So that's why I want to make the points under idealized conditions, because sometimes an owner will come to you, if you're the designer or the builder, or come to me on the energy model and say, well, you know, my building's using more energy than the energy model predicted. And so I have to explain to them that it is not a predictor of energy consumption. What it is very good at is it is under these same set of assumptions right here. Right here you've got the set of assumptions. And as long as you don't change those assumptions, what it's very good is evaluating alternatives. Window fenestration A versus B. This kind of HVAC versus that kind of HVAC. As long as you've got the same assumptions, even if they're not perfect assumptions, then the differential between the two is valid, and you can make a bona fide, intelligent business decision on, yes, I should spend more money on better glazing, or I should spend more money on better lights. But that doesn't translate back into, therefore my utility bills are going to be $1,000 a month. Any questions or comments about that? Sir, what's your name, sir? Bruce.
I was just curious about when you model this, what are you using for utility costs?
The energy modeling rules allow you two options. You can use actual energy costs for the building, wherever it is. So we talk utility company, or talk to you and find out what rate schedule you can be on. Use those exact numbers. Or you can use like a statewide average. And we will look at both of them and see which one's going to get you the most points. So it may be the actual, or it may be maybe the other number. Great question. Anybody else? Anytime, just shout it out. So, we think that energy modeling should occur during the design stage and not after the building's built, because energy modeling is a valuable tool that can help you inform the design and truly optimize energy performance for your building, for your owner, for your client, for yourself. Case in point would be kind of like the fenestration example right there. If you're the architect or the owner, you might say, well, gee, should I spend this extra for this better glazing? You know, the glazing salesman's been by my office and he's been telling me this and telling me that and how great this product is. Should I spend the extra for it? Well, once your energy modeler has built the energy model, it's just a computer program. It's just a few keystrokes to evaluate the different solar heat coefficients. Excuse me. So we can quickly make that evaluation for you, and we can give you the answer back in dollars. So it's not BTUs or kWh or something else obscure, it's actual dollars. And then you can say, well, I'll say X dollars, it cost me Y. Is that a good payback or not? And make an informed decision to design process. And sometimes the answers will surprise you. We were working on about a 60,000 square foot library in Savannah, Georgia at one time. And the architect said, this doesn't happen. You don't get calls like this very often. He said, that's some money left over. Like, I should have taken that call, right? So he got some money left over. He says, we've got some room, it had a slope ceiling, we've got some room up here, we can put in some additional insulation. Should we do it? More than the code required. So I said, well, let me find out. And so we did the quick evaluation, and called him back and said, no, we shouldn't do it. That you have reached the point of diminishing returns. You're already at the sweet spot. It won't help you at all to spend another $15,000 on insulation. Spend it somewhere else. So I'm glad you did. But I say that's a little bit counterintuitive because you might think, well, more insulation the merrier. But if you're an energy engineer like I am, or you study the subject matter, you know that after a certain point, you know, if you add an extra blanket, once you're warm enough, adding an extra blanket doesn't do that much for you. So it's an energy modeling tool. You should use that tool. And use that to evaluate trade-offs between alternative scenarios, between this kind of HVAC system and that kind of. Questions or comments? Okay. All right. The other interesting thing to know about energy modeling is the whole building simulation. So the effects and the changes to one energy consuming area, it's all viewed synergistically. So if you put in improved lighting efficiency, for example, then that's going to reduce your lighting energy consumption, but it's also going to reduce the heat load in the summertime. So then you might, if the improvement's big enough, you might come back and say, well, I just spend 10 tons or 20 tons of air conditioning in my building, which means you can put in a cheaper, not cheaper in the sense of less well built, but smaller, let's say, smaller cooling plant in the building because you've got better insulation and better lighting. So this program is smart enough to figure all that out to help you, again, make a truly informed design as you go forward with the project. And the other reason to have energy modeling occur during design, and somewhere in DD, once the design is far enough along, it's kind of, you know the building shape, you know the footprint, you know the orientation is kind of set, that because the longer you wait, and good ideas come along and you're in CD where the building's built, then it's going to cost a whole lot more to change it, obviously, than if you're still on the back of the napkin or the back of the envelope, you're playing with ideas about building orientation, things like that. This is a very logical thing. You've probably seen charts like this where the longer you wait, whatever the decision is, the more cautious you change. Questions or comments? So, and here's just some of the kinds of technologies that we help people evaluate with energy modeling. Solar orientation, glass orientation. It's actually really important, especially here in the South, to maybe put as much north glass as possible, as little west glass as possible, because we're hot afternoon in the sun or summertime, helping you optimize the envelope in a number of different ways, not just insulation thickness, but colors and envelope control, filtration control. Optimize the glass U values and SC solar coefficient glass. lighting, watts per square foot, WSF, high efficiency, HVAC. Those are the common things that we see parametrically that we're playing with in energy models. Real popular, I don't know if y'all are doing any of these, variable refrigerant, they're very popular, and they're kind of expensive, but they're very energy efficient. They give you a lot of good user growth.
Something a lot of people aren't aware of is that if you have more than 40% glass in the building, you have to have daylight controls. I've had a couple of projects which talked about that recently. Had they done an energy model or a comm check, they would have realized that early on instead of that last minute.
Oops, so that goes back to the other chart. You're an architect?
No, engineer.
What's your name, sir?
Garrett.
Garrett. So, that's, that point's, very, very valid. And, what did they do? Did they have to make those changes? Gary?
I'm sorry.
Did they have to make those changes?
Oh, yeah.
Yeah. Another thing about the 40% is that 40% glass is the magic number for the building code. And if you go over 40% glass, then you have to make it up, not just with daylight, but you have to make it up somewhere else in energy efficiency. So if you have building, the base building, we're going back to the energy model now. If you have the base building is 50% glass, well then the base building is 40% glass, because that's what the code requires. Well, your building has 50%, it's like you've already got one arm tied behind your back. We had a project early on that was almost at the gas code. So it's uses an annual energy use. There's these energy models run one calculation for every hour of the year. So it's called 8,760 hours a year. So it's called hourly annual energy use. There's a comparison between the base building and the design as a design. And again, focus on the differences between the two, not the total cost. That's not going to be accurate. It's not going to be what the bills really are. So here you go. Okay. So here's an example of a project. It's one of my favorite projects, not because it's so beautiful, but because we ran the table on this project. We got all the energy points, maximum cost. And in case you're wondering, the one on the left was before. In case you're still wondering, the one on the right is the architectural house. Okay, this is an old muffler shop. It was built in the 1950s, and it was concrete block. No insulation, I mean none. I did this project personally. It was just blocks stacked up. The roll-up doors, you can see them in the picture right there. They're just the thinnest, flimsiest possible metal, and you can almost put your fist through it. It was a very poor envelope. And when you're doing an energy model of an existing building, you get to take the existing envelope as found, not a code compliant envelope, which would be the case for a new building. But if we were renovating this building, we'd take that envelope as found. And I don't know what's behind the wall, what's good, bad, or indifferent. But when you have a really bad envelope for the energy model, that's really good. So we were just so excited. So, and the projects turned out beautifully. This is a super wide angle lens. The building isn't really misshapen like that. It's still a 90-degree turn back here, but where this is all north facing, by the way, so that's now the studio with all the nice north facing glass. Very successful project. And like I said, they got all the energy points possible, so I'm particularly proud of that one. So energy efficiency, it helps you reduce the total cost of ownership. It earns more LEED points, up to 19 points in LEED version 3. And how many points will it earn in LEED version 4? 20? No. They went down 18. Increase the value of the property because your owner is more, the building's more energy efficient, so you can sell it more on down the road. And it could result in a tax deduction for your client or even for you. There is a federal energy tax deduction of up to $1.80 per square foot. So if you're working on an energy efficient, and this is very energy efficient by the way, it's a pretty high bar, you have to be 50% better. Pretty high bar, but if you're working on an energy efficient building and it's large enough to make for $1.80 per square foot to make a difference, you should really focus on that. So if we were doing this building right here, it's not small enough, but $1.80 times the square footage of this building, 10,000 square feet, wouldn't probably be enough to really fool. But if you're doing a warehouse that's a couple 100,000 square feet, now you're talking. What's $1.80 square foot? Sir?
We ran the numbers on the IRS 179D, and we came to the conclusion of around 30,000 square feet or larger, it made sense to spend the money
To go the extra effort.
because it's the HVAC, the lighting, and the envelope.
And you have to do an extra energy model.
Yeah.
So I'm just thinking about that. You have to pay somebody an extra fee because there's some arcane rules that require additional energy models to be done.
Yeah.
So you got to pay that off. So that's not probably an easy number. Even bigger would be better. And if your client is a public agency, i.e. not somebody that pays taxes, then Don, you can have those tax deductions passed through to you. We have. Bravo. Okay, so there you go. So we'll look at that. Okay. Any more questions on energy modeling before we move on to commissioning? James, how's the time?
You have about half an hour.
Okay, perfect. So commissioning is a systematic process of just making sure that the building is designed right and works right and meets the owner's needs. It's inspired by the Navy practice of shakedown crews. It's just simply stated, making sure that the building runs right. And since it's inspired by the Navy, then I put a picture of the Navy ship. And a shakedown cruise means that when the military, the Navy takes delivery on a battleship or a destroyer in this case, they don't just take it right into battle, they take it out to sea and see what shakes loose on it and bring it back to port and get it fixed, tighten it up, and go back and back, out and back, out and back. And while they're doing that, they're also training the maintenance people and the operating people to run it right so that they know which switch is forward, which comes backward. Well, same thing with buildings. Buildings are machines. Buildings are machines, right? They're all full moving parts. They just go, we need to die. So this really is another shakedown cruise on this is what we're doing with commissioning, is making sure everything works right and that the building personnel are trained like they're supposed to. So why is commissioning necessary? This slide, which on my screen, it's filled in over here. I don't know why it projects this way, but that's actually a complete circle. And so back in the old days, the dinosaurs still roamed the land, and Don and I were young architects and engineers. The design team would consist of an architect, a couple of engineers, a GC, a couple of subs. That was it. That was the whole thing. That's all it took to build the design for the building. So somewhere in the mid-1970s, you could kind of argue whenever this took place, but somewhere after the mid-70s, the electronic revolution came along and PCs came along and buildings got smarter and better, and today's buildings are indubitably better than they were in the 1960s and 70s in terms of performance, functionality, and energy efficiency, but they're also a lot more complex, and there's a lot more players. So now besides the architect, mechanical, electrical engineer, you have a data consultant, a lab consultant, and a kitchen consultant, and on and on and on. And then likewise with contractors, you've got all these different teams now that make up any kind of facility. And so when you have these teams, then all these various people that are with different firms and they don't even know each other, then you start to have little gaps. And what happens to stuff when you have gaps? Things can fall through the crack, right? So commissioning part of commissioning is that the buildings are more complicated and the design and construction teams are more complicated now than they were decades ago. And that's pretty much mirrored the growth of commissioning because commissioning's been around since the 50s, but it was like, who did that? And now it's a necessity for a lot of buildings. And we'll have owners and architects or others come to us sometimes and say, well, gee, didn't I already pay for that? I hired the best architect in town, and I've got the wonderful contractor. Aren't they going to build me a perfect building? I'll say, maybe, but remember, every building is a prototype. Even if you build two buildings side by side, there's going to be enough of a difference that every building really is kind of unique in some way. The typical design, AIA design professional agreement does not require a third set of eyes from commissioning agent, CXA is shorthand for commissioning agent, doesn't require quality control but beyond field observations. So the architect or the engineer will come out to the site during construction, the plans will verify that the height is right, the light switch is over here where it's supposed to be, they don't actually turn it on and make it run. And that's one of the differences between commissioning and punch list is that, let me put it this way, Bruce, have you ever bought an automobile? Okay. When you bought the car, did you just look at it and say, I'll take it, or did you look under the hood and take it for a drive and roll the windows up and down, make sure the radio works, Right, this would be, that's the difference, is that we take the building for a drive. We make sure that the radio comes on, the lights work, and all that sort of thing. Likewise, for a construction contract, frequently commissioning CX is not even mentioned at all, or if it is, it's very informal. It might say, for example, the contractor will provide the commissioning agent. Well, that's sort of like letting the Fox provide the security service for the hen house, right? Performance criteria are not stated, and there may not be any independent witness test. So that's kind of an argument for why you're not really paying for that after all, Mr. Rogers. So the benefits are good energy efficiency, good IAQ. Anybody know what that stands for? Who said that?
Give us somebody else.
Audrey, can you catch it? There you go. IAQ, very wrong. Reduces construction costs, reduces operating costs. It's a LEED prerequisite and a credit. Anybody know what LEED stands for? Leadership in. Who said that? Okay. Here. This will go through the teeth. Okay. And it complies with guiding principles for federal projects. So, reduces construction costs. Well, that's pretty bold. How do I back that up? Because commissioning can help you find problems early while they can still be fixed economically. In fact, a large study of buildings was done by Lawrenceburg Laboratory a few years ago. They studied several hundred buildings, and they found an average of 28 efficiencies per building in new construction. So that's one of the goals of commissioning, is to help find more than that. It's just an average. You know, I mean, the Great Lakes are only a couple of feet deep on the average. Right? Think about it. People drown in lakes that have an average depth of a few inches. Right? So the average is anyway, it's 28. I digress. So commissioning is supposed to catch these, or at least as many as possible, so you don't have to. In fact, the same study found that over 60% of the time, commissioning paid for itself before construction was even complete, and avoided change orders or avoided project delays. So here's an example, real life example. We're working on a project that's got a bunch of, it's got ductwork going along the outside wall right here. Right up here, we're walking through the building doing the mechanical rough-in inspection. So this means that the ceiling's not in yet, so you can still see what's up there. You're likely to see that ductwork right there. So we're walking along, and we saw they have the VAV units, variable air volume control units, and this run of ductwork going along the wall here, and the VAV unit has an access hatch for maintenance. The access hatch is over here on my left hand, and it's supposed to swing open. Are you a mechanical engineer? Okay, you're nodding. So it's supposed to swing open like this, so somebody can get in there and change the motor or do something. But it was so close that you couldn't maintain anything. So we noted that, we commented on it, and everybody said, oh, you know, we got to fix that. Let's move the ductwork over, because it was early in construction. Nobody come along and put the sprinkler piping in or the lights or anything else, so it's no big deal. But what if that had been discovered after 100 of these had been put in, and now the sprinkler piping's in, the lighting's in, and now you got to move a bunch of stuff to move that out of the way? Well, then there'd be a lot of gnashing of teeth, pointing of fingers, claims, and so forth. So it's just a good example. I can give you many more of machines were avoided through commission. Questions or comments? Okay. All right. Also, for enhanced commissioning, there will be a design review and a submittal review performed by the enhanced commissioning agent. So you'll have another set of eyes and ears looking at the project for you. It's actually very valuable service, actually. Commissioning can also reduce operating costs. The same Lawrenceburg lab study I showed you, I told you about, has found an average 4.2-year payback on commissioning. Now, how much are you getting on your money in the bank right now? Less than 1%. Okay, if you take payback and do the reciprocal of that, that's the percentage of return on investment. So 4.2-year payback is like getting 25% of the money. So your 1% or less than that in the bank, it's actually less than 1%, is like 100-year payback. So this is very, very good payback, ladies and gentlemen. And if you're doing it, if it's an existing building, such as the one we're standing in, and we do retro commissioning, which is a building tune-up, an average of 1.1-year payback. So It's a very smart thing to do. You're not in the area, it's just an average. Just an average.
Is that the cost of the service or the cost of the repairs?
It's the cost of service. But a lot of times the repairs, a lot of times the building's just out of sync, and it just needs controls calibration. That's the biggest, that's the thing we find most common. Construction's problem found sooner while still under warranty, because if you have enhanced commissioning on your project, it's going to be a 10-month warranty walkthrough. How long is the warranty on most HVAC equipment, Gary?
3 years,
3 years.
parts and warranty.
Parts and warranty? 3. Usually, I usually hear 12 months. So we try to get the warranty walkthrough done before the 12 months are up, before the contract warranty is up. So that's the 10-month warranty walkthrough. And it also includes training of operating personnel. Remember the shakedown crews? You want to know how to operate this battleship before you face off against the enemy? So you need to train on that. There's 2 types of commissioning. There's fundamental commissioning, which is basically construction phase. That's what you think of when you see the commissioning agent, the hard hat, the clipboard, the digital camera walking around the building. That's construction phase commissioning. That's what we were doing when we found the ductwork with the VAV unit that wouldn't open. Enhanced commissioning is not construction phase, it's before and after. So it includes the design review, the submittal review, pre-construction, and then post-construction, the 10-month warranty walkthrough. Systems to be commissioned under a lead project are the energy-using systems. Just the energy-using systems. So that's generally interpreted to be HVAC, the lighting controls, not the whole electrical system. We're not looking at the panels, we're not looking at the roof generator, we're not looking at the switch gear. It's just the lighting controls. That's the part that uses energy. And in the plumbing department, we're going to look at the water heater. DHW stands for domestic hot water. We're going to look at the hot water heater and any associated controls or circulation options, because that's the part that looks at uses energy. So we're not going to be looking at the whole plumbing system and seeing if the standpipes are the right size or anything else like that. It's just those 3 things, right? And my own experience is that about half the effort is planning and paperwork, kind of getting things ready, or holding meetings, or writing up meeting reports, and then half of it is the fun stuff out in the field with your hard hat on, looking around, trying to figure out what's going on in the field. Questions or comments? Okay. So, commissioning of MEP, mechanical electrical plumbing systems, they'll include, if you have enhanced commissionings, include design review by PEs, installation inspections, the HVAC rough-in that I talked about, functional testing of equipment. This is where we actually get behind the wheel, start the engine, take it for a drive. We're actually going to run your equipment through all its modes of operation. So there'll be a normal mode, there might be a nighttime mode, there might be a power out mode, there might be a fire safety mode, there might be a freeze protection mode. We're going to run it through all these modes and make sure that it does what it's supposed to do. We'll do some data logging of interior comfort conditions, and then visit the training and skills on the optional. And we're getting more call for this nowadays than we have just the last 2 years, this envelope commission. Do you hear much about envelope commissioning?
I wish more people did.
Well, some owners wish they did more of it too. So we've actually got somebody that's providing envelope commissioning now. So it takes up about half his time in our office. In our office, 12 people, so that's pretty significant. Because people are tired of having leaking buildings. And we just finished one down in Tulane, which of course was hurricane site. That's Tulane University, that was a special treatment. Yes, Jim?
Your previous slide showed the second line, thermal performance continuity reviews. Do you do with that?
Yeah.
I mean, what do you do when you're doing that?
What is it?
Yeah, what is it?
Okay, metal conducts electricity, but also conducts heat. But fiberglass insulation doesn't, wood doesn't. So thermal performance continuity review is looking to see if there is there a short circuit between the inside and the outside that would conduct heat either in one direction or the other. So that's what we're looking for there, is make sure there's a thermal break everywhere it's supposed to be. There's not metal studs going right up against the metal skin of the building, which would be a great conductor. Thermography. Anybody want to know what thermography is? I'll let you know that word. Thermography.
Pretty pictures.
Very pictures, yeah. lots of reds and blues and purples. It's an infrared view of the building, and so you can have, if you have a thermographic camera, you can take pictures of this wall right here, especially on, if it was like a really hot day or really cold day, you have a lot of temperature difference between inside and outside, you can see where all the heat is going, or from the roof too, and where water is. But that's another story. Life safety systems is not part of fundamental lead commissioning. It's a darn good idea, and especially in university housing, you get a lot of requests for that as an added service because it's so important. I mean, it's important everywhere. University housing people seem to be much more tuned to it than a lot of other places. If you're doing a lab building, labs are tricky. And laboratory system commissioning is also an added service, and it's very complex. And these fume hoods are supposed to play well with the HVAC system. They blow it up. Something's supposed to happen in the HVAC system that controls the volume of air. But if they haven't been commissioned and synchronized, they may not work. And here's an example of that. Is that we were doing a project from Medical University of South Carolina. Big bioengineering building. We're going to be working on all kinds of stuff. You want to know where it is. It's here. It's not there. It's not getting out in the hall. So we had 3 commission agents down there walking up, so they were all over the building, communicating with each other, testing out the various systems. So we talked to the HVAC installer and controls installer. He said, all my stuff is working fine, and we checked it out, and by George's stuff was working fine. Then we talked to the lab contractor and the lab consultant. He said, all my stuff works fine. We checked it out, his stuff worked fine too. But they didn't work fine at all when they were together. So we had one person here with a walkie-talkie, someone else at the controls commanding the various things that happen, and a third person in the mechanical room with a flashlight looking up at the HVAC system. And they weren't working together at all. And that's so fortunate that got caught, because that would be a serious problem, and lots of finger pointing after the fact once we got it. So if you're doing a lab project, you should probably have that condition. While we're on site, we don't have blinders on. We're lead consultants with EAP, so we're looking for other things too. So, for example, one of the most common credits that people go after all their projects, I don't think I've ever seen a project not go after construction IAQ management during construction. And there's only 5 things you got to do as a contractor. Most of the things I do already, but one of them is you keep dry absorptive materials, keep absorptive materials dry and clean before they get installed. You can't see this photograph, but there's about a ½ inch of dust on the floor here. And this is insulation, which fiberglass insulation, which has the capability of absorbing all kinds of things. And so we go through there, and I did this in person. I took that picture. The mechanical foreman was walking around through with me, and I said, well, blah, 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 you're not supposed to do this because we can see. I said, please keep the stuff covered up like the ones in the background here until the day you're ready to handle it. I said, okay, fine. Commissioning, when you're doing commissioning, it's not a game of gotcha. We're not trying to make ourselves look better by making somebody else look bad. So I didn't write that up. It's like, okay, he heard me, and I'm not here. I'm not the police. I'm not trying to embarrass anybody. But if I went back 2 weeks later and it was still this way, then he hadn't paid attention to me. Then it gets elevated. Then this boss here's about it, the architect here's about it, the engineer, the contractor, and then it gets elevated. Just a cigarette butt, lead buildings are not smoking in the construction. This is a little excessive to me, but even during the foundation work, I mean, there's nothing there to absorb tobacco, so I don't see, I seem like a tobacco operator could smoke a cigarette, but it's not my rule, I'm just telling you what the rules are, so what can we point out? Again, we don't write it up each time. How much does it cost? Well, my answer is less than you think, and more and less than this worth. It's worth a lot more than this. Fundamental commissioning varies somewhere between 0.3% and 1.5% of total construction costs. Or as the LBL study said, somewhere between 35 cents and $1.64. This varies with building size and building complexity. So Don, if you come to me, you've got a 100,000 square foot warehouse, that's one thing. If it's a hospital, that's a whole different thing. So there's a lot of variability in there, but that's a pretty good range of cost right there. It should be somewhere between 25 and 35 cents a square foot to, if it's a really small building, could be $1.50, $1.75 for 5,000 square foot building, something like that. Because there is a minimum here of about $8,000 or $9,000. Even if you're commissioning a doghouse, you still got to get in your car, drive to the site, you got to do a report, you got to upload it, lead online. So even if it's just this, you're commissioning, you still got some fixed costs. So that's kind of that's reflected in this number right here. Enhanced commissioning is about 1/3 the cost of fundamental. So if your fundamental commissioning budget is $21,000, then $7,000 or $8,000 will take care of enhanced commissioning. Generally, there's again flexibility here. It's kind of a rough outline. Any questions or thoughts or comments? Yes, Gary.
Closing up the ductwork during construction.
Pardon me? Now?
Closing up the open ends of the ductwork during construction.
Well, that's one of these right here.
Okay.
Yeah.
All right.
That's one of the 5 things you have to do. First, Matt. So, yeah. Other comments? All right. So, we've got lead commissioning. It's easy to accommodate and relatively inexpensive to deliver. And we, even though strictly speaking, the owner's supposed to prepare the owner's program requirements and the architect's supposed to prepare the basic design, we help a lot. We work on, like I said, a lot of these, so we have a lot of stuff in Word, it's ready to hand you. All you gotta do is kind of fill in the blanks, try to make it easy for you. So why do commissioning? Because it reduces the owner's total cost of ownership, which nothing energy modeling does. Pays for itself with improved operations, avoided problems, better IAQ, energy efficiency. What owner wouldn't want a project with fewer headaches? What architect or contractor wouldn't love a project with few callbacks? So it's to me a small investment with a big payback. So here's a few slides of actual trying to express what commissioning is in words without using 1,000 more words each. So it has to do with responsibility here. I don't know, see what that is. I think it is not. Design intent, I don't know what they had in mind there. Or quality assurance. Now this is a good point right here. The commissioning agent is a QA, quality assurance, not quality control. The difference is we don't paint the sign, we just tell you what to spell it. So here's some actual photographs. I took all of these on projects and actual field observations. So Gary, you're a mechanic engineer. What can you tell me about this photograph right here?
Too much flex and too tight of a bend.
That's right. And it could lead to
Decreased airflow.
or whistling will do that work. Okay. So that's an easy one to fix. Because all it takes is a pair of scissors and a little bit extra of that nylon tie-in. Okay. Now this photograph, let me give you some background. This photograph was taken during a 10-month warranty walkthrough. Okay, so the building is built. It's been occupied. And what do you see wrong in this picture? Wayne, you're a smart guy.
Can't tell for sure, but is it just some electrical wires not connected to anything?
I'm not collecting anything. That's right. That's right. This is in an architect's office. And they had a row of private offices along the north side of the wall there with occupancy sensors in there. They're supposed to, with daylight dimming sensors that were supposed to turn off the lights when the outside light was a certain number of foot candles. And so that was going along. And most offices were empty, but I came to one. There's Don sitting there. I said, Don, how's the lighting here? He says, all right, but I've got, every time I come in, it's just so bright, it's took off the lights manually. I said, well, let me see, what's going on. And so on the bottom side of the ceiling, there's a little round disc with a couple of buttons on it and an LED printout. I'm pushing the buttons, the motor's manual, nothing's happening, it's not coming on, it's not lighting up. I don't know, I can't see what the problem is. So I was standing on this ladder, and I wasn't tall enough to pick my head up above the ceiling, but I was tall enough to stick my hand up there with my digital camera and took the picture, pulled it down, and I could see the picture. I said, I think I see the problem. And that's the picture I took. And the whole roll was like that. And so the electrical contractor had to come out and take care of all that. Well, it's still under warranty. There you go, folks. Okay, what's wrong with this picture right here? Now, I know it's not covered up at the end. That's okay. This is a construction picture. Anything else wrong here besides Gary? Has to do with ductwork support. Ductwork is supposed to be supported on its own and not by the sprinkler system. All right, doing that good. We need to tighten up the game here. Okay, look at the upper left-hand picture. If it's big enough for you to see back there. And Jim, can you tell? I even made it easy to have circled something for you. Can you tell what's going on here?
having trouble seeing the picture from there.
Don, can you see what's up there?
Is that a pipe interfering with the valve or?
Well, that's a sprinkler. That's a sprinkler head right there, like we got right here. It's turned up. And then this little pipe right here, what kind of pipe is that?
It's like electrical conduit.
It's electrical conduit, right? What goes through the electrical pipe like that? Electrons.
In theory.
And, all right, question. Water and electricity, friend or foe? Okay, this was too close, so we had to get them to change that. Now this picture is actually, it's not a construction area, it's actually just kind of a funny picture. But the caption of this picture is do not use door 314, you know. Anyway, I just thought it was funny. This is not so funny right here. Anybody know what this is right here?
Outside air intake on the rooftop.
This is the outside air intake of this whole building. All the, quote, fresh air is going to come into that opening, that dark opening. What is this little thing right here, folks?
Restroom vent.
It's the toilet vent. Okay, how far is it from here to there? I know you're just guessing. 3 feet. A little too close. A little too close. Okay. So that needs to be fixed right there. That needs to be changed. So what should we do? How should we change that?
Well, you can do what some people do, just put a sleeve on top and make it taller than the rooftop.
That's about the only thing you can do cost effectively. That's right. Okay. This picture, I don't know why it's just coming out black on the screen, but that is red. And then if you look over here, you can't really tell. There's nothing. Anyway, this is fire stopping. But if you need fire stopping here, don't you also need it there?
Yep.
All right. So here's a few more. I think probably my favorite one are these two down here, being a mechanical engineer. I don't think this is supposed to be in the airstream. And then right here, for you non-engineers, this is the air supply, non-engineers. This is the air return. So this is like very, very energy efficient. Why waste a lot of energy moving the air through the roof? Just get in and get it out. All right. Okay, ready for your IQ test. Have you taken the IQ test?
Yes.
Are you ready? Okay. The lead project can earn the most points for A, fundamental commissioning. B, development density. C, energy modeling. And D, public transportation access. You can't raise your hand twice. It's like voting twice. I'm wise to you. Okay, the answer is energy modeling. You can earn 19 points, and then on your lead version 4, it'll be 18 points. Who got that answer right? The D's. Anybody else? Everybody's had it? Okay. All right. 2, enhanced commissioning and fundamental commissioning are both required by lead. True? False or varies with lead rating system? False. False is correct. Here you go, Don. There you go. All right. Lead B, D, and C. We already know what B, D, and C stands for, right? Audrey told us it stood for
Building design and construction.
Bravo. Okay. Which of the following are ways to meet the energy performance prerequisite and credit? Is it A, energy modeling? Is that one of the 3 ways? Okay, that's all we'll talk about today. Okay, you were awake. All right. Is it B, a prescriptive approach using the ASHRAE Advanced Energy Design Guide? We didn't talk about that yet, so you don't know the answer to this. Is it C, prescriptive via Advanced Buildings Core Performance Guide? Is it D, use ComCheck? Good, I didn't suck anybody on that. Is it the Living Building Challenge? It's actually A, B, and C. We didn't talk about the other 2, but there is a prescriptive approach if your building is a certain size and a certain type. And so for smaller buildings, we're doing like a 5,000 square foot visitor center right now for the state park. So we said, look, the energy modeling, it's overkill, just use this prescriptive approach. You'll get 2 points and you'll be done with it for a small project. Energy modeling can be applied to which of the following? LEED, I, D, and C. That's interior design and construction. B, D, and C, yes. LEED for schools? Yes, schools is part of B, D, and C. LEED E-bond? No. Or LEED for retail? No, because energy modeling does not apply to LEED, I, D, and C, and LEED for retail is a subset of that. So energy modeling is only needed for B, D, and C projects. Okay? All right, who can provide enhanced commissioning in a project greater than 50,000 square feet? Can it be an employee or subcontractor of the GC or CM? Can it be an employee of the AE? No. Can it be a subcontractor of the AE? Yes. It can be a sub of the AE. Can it be an independent consultant or owner? Yes. Yes and yes. Now, fundamental commissioning is a little more generous. In a project greater than 50,000 square feet, it could be an employee or subcontractor of the GC or the CM if they are not involved with the project. Same thing with the AE firm if he's not on the design team. In fact, all these are yeses. Commissioning a lead project, does it cover building envelope? No, it does not. Does it cover fire alarm? No. HVAC?
Yes.
Yes. Okay. DHW? Yes. Emergency generator and switchgear? No. Lighting controls? Yes. Okay, good. Good group. All right, fundamental commissioning can take place after the building is constructed. True? False? Or varies with the lead rating system? No, it's false. We found this out from a project that the owner wanted to go lead, then they decided not to. They went ahead and designed and built it, and then they came back to us afterwards and said, you know, we would like to be lead after all. We said, well, we can go down and commission it, but it's built. And so we had to find out by talking to some people at USGBC. Said, no, it didn't happen during construction. It's not a lead project. Enhanced commissioning can take place after the building is designed. True? False? Varies. Enhanced commissioning includes design phase reviews, but it can take place after design. We found this out on a project. If the owner agrees that if you do a design review retrospectively and you find something, they'll fix it. And of course, when you do the design review, you try to find anything really bad. But yes, it can be done. So that's kind of a quirky thing. All right. Can your owner use his energy model to predict his energy bills?
No.
No. Because you all know that one. Bonus question right here. True? False? Or varies?
Are you giving out candy on that one?
More candy. More candy. Candy for everybody. Okay. Summary. Here's your takeaway right here. It's a QA, not a QC process. Commissioning is to assure that the building is built right, runs right. Fundamental commissioning is a lead prerequisite. Enhanced is not. Pays for itself during construction more than half the time. Enhanced commissioning is a high-value service, not too expensive, that earns 2 points for NC and 5 for the CI project, by the way. Here's your takeaways from energy modeling. You need a 2-point minimum. You've got to do something. If it's not energy modeling, you've got to do one of the 2 prescriptive approaches. The threshold is 10% for lead new construction or 5% for existing building. May result in tax savings for you or your owner. It's a valuable tool to use during design and should occur during mid-DD. Please fill out the evaluation form and give us, particularly if you've got suggestions about do more of this, do less of that, or I'd like a topic on something else in the future. And we do give talks on other subjects, such as kind of a comparison of LEED, green globes, and we've got a new one we're just rolling out on LEED version 4, a sneak preview. I'm giving that one Monday to a group somewhere else. IGCC, what you need to know about energy modeling is the one you just endured. We've got one that's very popular right here, lessons learned from 200 LEED projects. So if you're a LEED practitioner, you might be real interested in that one. And then if you're involved with performance contracting, or if you live or work in Georgia, you might be interested in that one. So thank you very much. It's been a fun group. Good.